Neil Strachan. I'm introducing and chairing Catalina Spataru's inaugural professorial lecture today. I'm delighted to introduce Catalina. Due to COVID, Catalina was actually promoted at University College London to professor on the 1st of October 2020. So she's not a brand new professor, but with COVID, we've been waiting to do this lecture in person, and we've been waiting, and we haven't quite got to the end of COVID, and we're really keen that Catalina and our other new professors get to give a lecture, which is why we're doing it in this format. It does mean, though, that many people from outside London and perhaps even outside the UK can join us. So we're very glad to have you. Catalina is a professor of global energy and resources at the UCL Energy Institute. And the fact that she's her title is so broad really reflects her interdisciplinarity and her range of research interests, which I'm sure she will touch on. Catalina was the first female professor at the UCL Energy Institute. We now have two female professors, but it's fair to say that Catalina is as well as a world-leading researcher, is actually a role model to people in UCL and in broader academia in London and the UK. Since the 1st of October 2020, Catalina has actually become director of the overall Energy Institute. So she is now the big boss in what is the UK's leading and largest centre of excellence on UK energy systems and energy demand, and of course has much broader interdisciplinary links as well. So I'm going to hand over to Catalina to introduce her really interesting lecture entitled "Can't Go Green Without Blue." So I'm really interested to her thoughts on linking oceans and land and the broad issues around sustainability, climate change, and the energy transition. I would say that the format of this is that you can't speak to give questions. Instead, we're going to ask you to use the Q&A function. So anytime you have a question, just type it into the Q&A box. There is the option to vote up questions that other people have answered. So that means you don't duplicate questions. And if there's a topic you really want to have covered, then just either ask the question or upvote a similar question that somebody else has already asked. Catalina is going to talk for about 40 minutes or so, and then we're going to have plenty of time for Q&A. So thank you all very much for joining us. And Catalina, over to you, and I'm really looking forward to your talk.
Thank you, Neil, for the introduction. So can't go green without blue. I'm going first to take you through a gallery walk and mentioning a couple of challenges our societies have to address currently on land and ocean. This will be well known for all you, for sure. Climate change, energy provision, fuel poverty, sea level rise, and its impact on coastal areas are all these kind of global challenges, together with transition to a green economy that is low in carbon, socially inclusive, and resource efficient, highly interconnected and at a global scale. So as nearly we have 40% of the world population depending on marine and coastal biodiversity for their livelihoods, a blue-green wide approach needs to be adopted to re-energize governance of resources, of disaster resilience, improve human well-being and social equity. Also, policies are increasingly cross-cutting, covering different sectors and stakeholders with different networks and levels. So we have to re-energize a little bit our approach in science. I will first mentioning a couple of facts and numbers here. So more than 1.42 billion people, including 450 million children, live in areas of high or extremely high water vulnerability. Then we've seen an area of tropical forest about the same size as Greece. It's cut down every year. Then we have the ocean space, which could bring new opportunities for harvesting renewable energy and growing food. And we've seen like we have 680 million people live in low-lying coastal zones, and small islands developing states are home to 65 million people. So while sea level has risen globally by around 15 centimeters during the 20th century, it is currently rising more than twice as fast. So we've seen 3.6 millimeter per year and accelerating. So according to research, it could reach 30 to 60 centimeters by 2100, even if greenhouse gas emissions are sharply reduced and global warming is limited well below 2 degrees Celsius. So without major investments in adaptation, there will be escalating risk and consequences. Few more numbers I would like to give you here. The number of weather-related hazards, such as droughts, floods, heat waves, has tripled, and their frequency and intensity are expected to continue increasing, adding greater pressure on resource availability. And these risks are amplified by climate variability and change, and made more complex by changing patterns of human activity. So current data show that 1.6 billion people worldwide were affected by floods only between 2000 and 2019. Floods being the most common type of event, with an average of 165 or so events per year. Then droughts. Droughts affects Africa more than any other continent. If we look at the economic cost, counting the economic cost, recorded losses totaling 2.97 trillions US dollars from recorded disasters between 2000 and 2019. And we've seen storms cost more than any other disaster type in terms of recorded economic damage, followed by floods. And as climate change intensifies, we'll see increased flooding of coastal cities brought on by sea level rise, and taxpayers worldwide will be faced with more bills to clean up damage in the wake of these events. So a combination of rising seas, sinking land, growing coastal development could push global flood damages to well over 1 trillion every year by 2050, according with some of the research. But natural disasters hit everyone. However, most vulnerable get the burden. So over top of 10 countries' territories by economic losses as a percentage of GDP, 8 of the countries' territories are island nations, 7 of those being in Caribbean regions. So if we continue now with our gallery walk, adaptation and planning for future, so eliminating sources of waste must be one of the focus for every nation. Design and innovation are also key in creating products or buildings that are optimal for reuse, repair, and remanufacture. Water conservation is important because fresh, clean water is a limited resource as well as a costly one. Agroforestry is a land management approach that combines trees and shrubs with crop and livestock farming systems, a practice which can deliver a multitude of benefits both for the farm and for nature. Then green roofs, which can help reduce the heat flux through the roof, and less energy for cooling or heating can lead to cost savings. And green walls and roofs should be more widely adopted because of their vital role they play in the flood reduction, heating and cooling buildings, improving biodiversity and filtering air pollutions. Then we have zero waste, where the goal is for no trash to be sent to landfills or in the ocean. And we need to rethink also new houses construction. And here is an amphibious home, which is situated above the water, and these houses are designed to float when the water level rises. So this is an innovative approach to tackle extreme flooding, adapt to the challenges of climate change. So all these are just some of the examples of many other things which we can do. So tackling these global challenges, such as sea level rise, its impact on coastal areas, transition to a green economy that is low in carbon, socially inclusive and resource efficient, highly interconnected at a global scale, depends on optimal integration of resources in a synergetic way to increase community resilience under extreme climate scenarios. So a Nexus approach could help planners to understand potential trade-offs between resources, such as energy and water, or energy and food, to understand interlinkages, to emphasize the need for developing synergies and negotiating the trade-offs. So there is a need for more integrated approaches, capturing interlinkages between systems of provisions and how resources provide a basis for societies and sustainable development. And here you see that the first layer which gives categories of goods provided by the natural assets. Then you can have a second layer which adds the socioeconomic supply system based on such resources. And then you can see all some interlinkages which may be more obvious than others, such as the connection between energy and water. Others become more critical during periods of rapid increases in the use of one resource without assessing the availability of core inputs from another resource, such as material needed for energy production. So the Nexus approach provides relevant information about dimensions of critical interlinkages across resource sectors, space and time that enables the decisions makers to plan for more robust governance across resources and spatial scales consistently along the planning horizons. So analyzing some of these interlinkages and understanding what are those interlinkages could help us to connect across scales from small local places to more international trade and global cycles. And this is where Nexus could improve understanding of resource interdependencies, closing gaps between environment research or natural capital, ecosystem services, planetary boundaries and climate change, adding analysis of resource use and management. However, despite the considerable potential, we need to remain realistic about its limits, as any application in either modeling or decision-making in specific context will never be able to consider all interlinkages across all resources, environmental and socioeconomic functions and contexts. So to capture such interlinkages, a sensible next step will be to develop integrated tools capable of ensuring the dialogue between stakeholders to better understand trade-offs between sectors within the blue and green economy. As you can see here, resource use, the impact of coupling different types of systems with different behavior dynamics. And this could be a step forward and help design better policies and more efficient provision of public services. And such toolboxes could allow for the specific circumstances of different regions, or include high resolution representation of important components, and might apply complexity theory across physical, social, and economic science, and across temporal and spatial scale. So such approaches also might better support decision-making and policy integration among public, private, and civil society actors and systems. So what I would like here in this talk is to highlight a little bit the need for green-blue economy as a yin and yang through the lenses of a nexus. And I will be discussing my approach to complex problems, including how the blue economy contributes to climate change mitigation by developing, for example, offshore renewable energy, developing floating energy systems to power islands and coastal areas when disaster strikes, and support their transition to a green economy. So I will talk about I will mention the importance of a green agenda and how the contribution of a blue economy to its agenda provides opportunities also for businesses and communities to bridge vet governance gaps, and capture growth opportunities in different sectors. So in the context of global inequality, environmental degradation, and insecurity, the blue-green economy offers a vision of more equitable sharing of sustainable resources, provide opportunities for businesses and communities to maintain their highest utility and value at all times across scales in an interconnected world, contributes to climate change mitigation, to ultimately nourish prosperity and human health within the planetary boundaries. So I will give you insights into two examples of integrated approaches. I call them toolboxes. So the first one is the Blue-Green Islands Toolbox. So many ocean-based industries are growing faster than the global economy, and in many cases exponentially. We've seen already like nearly 1 million kilometers of fiber optic cables which have been laid on the seabed to carry 99% of our international communications. We've seen offshore wind energy capacity increase 400-fold. So the motivation of looking at islands' energy demand and supply, interconnections with the mainland or other islands, the trade-offs between resource use came from how creating an interconnected system that would move, in the case of electricity, how you could move electricity, for example, from one region or even a country to another, which could help foster cooperation between nations, including the one with small-scale economy. So this is very much similar to how social networks work to see, for example, a homeowner in London which will capture kilowatts hour for sale to a homeowner in Brazil or San Jose or to Shanghai. That might sound a little bit like a pipe dream, but it could be to explore a little bit to see what will be the way moving forward towards that. So the technology needed to build such interconnections exist today in the form of high voltage direct current transmissions, known as HVDC. And we've seen 50+ years old HVDC technology is now mature, reliable, acceptable globally. And from its modest beginning, the technology has advanced considerably and maintained its leading edge image. And cost also starts to come down as well. So today, HVDC transmission is all around the world in more than 100 projects, as you can see in this map. And in addition to the HVDC projects, there are also several ultra HVDC projects around the world, which are in advanced stages of planning, some in the execution phase. And these undersea cables move electricity produced by offshore wind turbines to land through a series of cable systems that are buried in the seafloor, and transferring the electricity from the regions that need it least to those that need it most. One solution to this to make the grids that distribute the electricity bigger creates so-called super grids. So the base idea is that if energy is shared over a wider area, there is more chance that the sun will be shining or the wind will be blowing in one part of the supply network, if not in another. So the super grid could make the world a lot smaller and connected. But the problem is still financially. So the cost of building such a grid and transmitting electricity over very long distances can be inefficient in some cases. And many countries will need to upgrade their power lines, cope with it. And of course, there are political considerations too. And energy security is already the main driving force in terms of the geopolitical landscape. So the Blue-Green Islands Toolbox consists of a number of components of that. So consists of ISLA model, which represents demand and supply. I will talk in a minute about that one. When I developed ISLA model, I've done it a few years ago for starting with for the teaching purpose and research purpose. And one version, it has been used by master students and PhD students in their research. And now we are having a portfolio of more than 300 case studies. Then we have a maturity index based on indicators and metrics, and a metadata base accumulated over the years for islands. Of course, part of this toolbox, the key part is interaction with a wide range of stakeholders and validation of the tools and gathering the data which we need for this. So this is the simulation model. So this is to give you a bit of an indication how it looks like. So it was developed to analyze the future energy supply and demand scenarios based on changes in historical trends, technology cost and performance, policies and regulations. It calculates total electricity, heat, gas, oil, and biofuel supplied up to 2050, electricity generated technology, fuel required, total carbon cost per fuel type, carbon dioxide emission per technologies. We have some calculation on the levelized cost of electricity production per technology and electricity cost per person. It requires input data on sectors. On domestic, industrial, services, transport, and so on, population, households, efficiencies, transmission and distribution efficiencies, then electricity supply mix per technology, power plant efficiency per technology also is needed, fuel prices, capacity factors of power plants per technology, investment cost, operating maintenance cost, carbon cost, and lifetime of power plants. So first I started with energy, and then I extended to water to catch some of the interlinkages between energy and water, then extended to land. And then one of my researchers did materials, and we have some, we capture also for some cases food as well, but some particular interlinkages, not really. So for water, there are two types of water usage which are calculated: consumption and withdrawal. Water consumes the amount of water removed for use and not returned to its source. Water withdrawal is the total volume removed from a water source, depends like a river or a lake or so on. So in order to calculate the impact of material data, for example, for material requirements for low carbon technologies like solar PV or heat pumps or so on, depends on the case. We have amount of material types and energy requirements for heat pump, gas boilers, solar PV, and solar thermal, which are provided. And then we use conversion factors for each material type to calculate the greenhouse gas emissions. So while calculating the emissions, manufacturing, assembly, maintenance, and the decommissioning phases, then we include that into the calculations, and then we calculate waste and recycling waste, landfill waste, and recovered waste amounts are needed to be inputted into the model. And in many cases, it's a problem of finding those data. Then we have the Circularity Islands Maturity Index, which to move more towards a green economy, there were several changes in various sectors and needed to be made. And as islands are expanding on tourism, for example, with new buildings being constructed each year, then a system of indicators to measure and monitor the full climate impact of buildings should be established. So that we had in mind when establishing this index. So a low carbon economy also needs more materials and waste. Renewable energy needs more steel, heavy rare earth metals needed for a number of applications. And then we have energy infrastructure, which needs also other materials like steel, copper, nickel, and cement, and so on. Sustainability buildings also require stronger, more flexible and lighter materials. So we try to look at some of the connections between current SDGs, and we determine a number of indicators for islands specifically, and then we define the circularity indicators in line with the SDGs, and then we assess the SDGs and their relation, and then we design the conceptual framework for islands specifically to look at the products and services and the correlation and the connections between indicators and SDGs. And here is the samples of some of the outputs which you can generate for samples of islands depending on the data. So something what I really believe strongly is when creating this type of toolboxes is that bringing together communities and businesses will enable islands to become reproducers of resources, richer than producers or receivers of waste. So responsible consumption and production is a really key step, and sustainable behavior need to be directly integrated into the business models and practices of companies, municipalities, and residents. And at the core of it, I put communities and businesses here because where governance plays a central role in decision-making in terms of regulations, economy, and education, business and communities are equally part of the problem. So there is definitely more is needed to be done so companies to embrace circularity in their services, to measure sustainability, to understand how community embrace circularity through education, where reduce, reuse, and recycle concepts have been applicable to resource use, product, services, and production in the supply chain as well. And combining all these aspects together is necessary to determine how ready businesses or communities are to move to circular economy. But it's not simply recycling, it's also upcycling and making sure that the materials that we put in our products can be also upcycling and used in a new product. So if we want to move to the transition to a green economy, it really depends on the whole communities and businesses and governments and everything to get understanding of all those trade-offs and interlinkages. So plans for energy islands have over the last few years emerged as some of the most ambitious in the global energy transition. So far, most offshore wind arrays have been connected to the onshore power grid individually or to onshore converter station that bundles the power of 3 or 4 wind farms together via high voltage direct current linked to shore. But the next decades will require a think of how grid connection is organized, how quickly new capacity can be added, how to do the most economically, how to do that most economically, and how to do so without using up too much space. And despite the complex engineering challenges and massive volumes of sand, rocks, and concrete needed to build them, artificial energy islands made of modular interconnected systems may offer a cheaper alternative for grid connections than multiple conventional offshore wind substations and converter stations. So the energy islands are also being suggested as potential hosts for offshore wind power green hydrogen production, for example, and repository of battery storage. But it's really vital that the green transition goes hand in hand with protection of nature and wildlife. So some studies shows that artificial islands at some 80 kilometers from shore would actually be some 10% cheaper than connecting the wind zone to the mainland via offshore platforms. So it's we looked a little bit more in depth into that, and we are currently looking at the microgrids, which traditionally thought as a method through which communities or businesses improve their resilience when confronted with electric grid outages. But what we are looking is to look at ships and boats, private boats even, or all sorts of boats to act, which could act as a microgrid. So we are currently evaluating different configurations of microgrids for disaster preparedness and recovering, as blackouts due to natural disaster events often come at an extreme high cost to power grids, and businesses and society overall with cascading effects as well. So the idea is to have a type of ship microgrid, which largely self-sufficient when it comes to power generation. But there are situations when the ship sometimes must go onto shore power and plug into the grid, what's referred to as cold ironing, we say. But when a ship goes into a port with strict air quality measures, a ship might switch off their diesel gensets and use shore power instead. So from the perspective of a grid, when it's connected, it is a single electrical load, and the grid operator has no visibility into the discrete electrical loads on board that ship. So in other words, electrical boats not only transport people and goods, they can also become floating microgrids and virtual power plants. So we explore in this moment how reliable such a cluster of microgrids is in case of a disaster response, and how could this kind of cluster be utilized as a plug and play when load demand is high. So this is very much to understand that you need to understand, as you see, what is the demand and supply for both islands, what is the interconnection between them, what is the potential, the trade-off and interlinkages with our resources, and what other systems we can bring into this interconnected system so could be reliable and affordable. But most importantly, what we are really interested in is about when a disaster strike, then how reliable could be that. So probably all this sounds really like a fairy tale, but definitely it sounds like a fairy tale, but we look at the benefits and challenges for this type of interconnection extensions from technical, economic, and environmental social perspective. So you see here a number of pros and cons. I put that. So in the event of a disturbance or emergency in a country, this kind of interconnected grids could improve the security of supply and grid reliability by providing electricity from these neighboring interconnected microgrids. Unit cost of new generation transmission capacity generally decline with increasing scales up to a point. But sharing resources in more interconnected system could allow construction of facilities with lower unit cost. There are other issues there in terms of market integration, what regulations you use, who is zoning that, and so on. There are also limited investments. There are also issues related to political and security instability in certain parts of the world. So there are many things which needs to be considered. However, we are looking to see how feasible is that concept concept in practice. I will give you just some samples of analysis we have been doing. So, for example, for Cyclading Islands, as we looked at it as a wind hub, we identify application submitted on the islands for wind energy projects, and then we assess the most major projects, and we estimated the expected power generation for that, total cost from the investor perspective and public perspective. The proposed plan does not include all the license projects in here, but those projects close to the implementation stage were selected, so we can to follow a more realistic plan of approximately 250 megawatts development for these islands. And through the analysis, we've seen that the investments which are needed, and by 2025, for example, we've seen that wind energy capacity is still low because of the project's capacity, timeline, and maturity, which do not allow for implementation of additional farms in order to fill that 30 megawatts gap for this case. So also from our analysis, the annual balance of demand and supply will allow export of power from the Cyclading Islands after 2025 to the mainland, and that is about like 100 gigawatts hour per year by 2030, creating a wind energy hub in the area. And this figure shows you compare the internal rate of return value of and levelized cost of energy of the wind projects, demonstrating that highly efficient projects have lower levelized cost per unit of power. And behind the enhancement of a local power network and energy security improvements, our study also proves that through an action plan that interconnecting the Cyclading Islands will provide both economic and environmental benefits to the Greek energy sector. So by selecting information for the wind speed potential of the area, current and future license project, as well as the technical characteristics of interconnection in parallel with the wind energy development plan by the Hellenic Independent Power Transmission Operator, then an action plan is proposed for developing 260 megawatts of wind farms in these islands. Another examples we assess is wind offshore energy in the northern Aegean Sea, Icelandic regions, where we configure an efficient wind offshore project in terms of sizing the seating, environmental impact, and interconnection design. So we looked at the optimal combination of energy resources, electricity generation technologies, and interconnection cables to satisfy the future electricity demand and ensure all the specified constraints and targets under the criterion of the total power generation cost minimization. However, careful consideration should be given in terms of decision making, and here I map locations where boron material, which is boron production processings, are likely to influence the environment. Boron is a material which goes into these cables. And the message is really simple here, is the production and processing of source materials can have direct and indirect implication in the environment. And once this interconnection expands, the market for these materials then will expand as well, and we can expect environmental effects as well. So in principle, policymakers acknowledge the importance of integrated planning, but in practice, it has been hard to do so. There are technical institutional hurdles there. And there is also knowledge gap in terms of resource interlinkages in the measuring, which is a really major impediment towards improved policies, I would say. Another example is a toolbox I developed for the current project I'm leading, which is re-energized governance of disaster risk reduction and resilience for sustainable development, which is a collaborative research action on disaster risk reduction and resilience through the Belmont Forum, supported by funding agencies, 4 funding agencies from UK, Qatar, Japan, and US, with partners from UK, Mauritius, Ghana, Qatar, US, Japan, and Italy. And what we are doing here in this project is to address the simultaneous interactions between climate-related natural disasters and development for effective disaster risk management, acknowledging the role of community involvement in disaster risk management planning and the role of legal principles and institutions in reducing asymmetries in knowledge and power within a society. So the project innovations is to develop a interdisciplinary framework and empirical advancement to tackle complex systems challenges. And the key is likely to be to draw system boundaries wide enough to look at the interacting vectors while maintaining useful in terms of analysis, small enough to be able to conduct useful analysis. So I developed a toolbox, and together with my partners, we finally had really several discussions about how we interlink all these tools, all these methods. So the toolbox consists in different methods and tools all interconnected. So here I simplified them in 4 interconnected main topics. So we have a diagnosis and stakeholders processes, we have a social media data and data processing, everything related to artificial intelligence, and then we have a resource nexus and climate change modeling scenarios of different sectors, resources, and so on. And resource allocation, and then application to coastal cities and islands as case studies, and the continuous interaction with stakeholders in different locations. So we started with the screening of legislation, policy measures, and governance arrangement mechanisms, and then we created the DR3 diagnosis catalog, which we consider finance, policy, opportunities, learning, innovation, path dependencies. And then in parallel, we looked at the global agendas, SDGs, climate change, and Sendai framework. We formed analysis of metrics to derive KPI for equity, DR3. And then together with the diagnosis catalog, we developed a DR3 balance scorecard. In parallel, we put in place a process for stakeholders through use of a number of methods and through triangulation and KPA. Then we define the best practice sectors to inform the resource nexus tool when defined scenarios. We then have the social media collections with the tool from Qatar. And then we had to develop our own data processing and filtering approach with machine learning training tools and the sentiment analysis, in which could inform the stakeholders' engagement as well as the specific application to case studies. So in other words, our approach is cumulative and in combination. And we started to, we have a number to apply once we finish the development of the different tools and the interlinkage between them. Once we have a toolbox, then we will apply to case studies. Accra and starting with Accra in Ghana and with Mauritius Island. But we have a really wide range of stakeholders from other islands and cities like Fiji Island and cities like Marseille and Sao Paulo to validate our toolbox. And here you see how we validated our toolbox. So these rows here, you see what we cover with our stakeholders to validate our toolbox through workshops with stakeholders. So First was in different sessions. So first was validating the balance scorecard, which we created. Then was looking at different processes where we discussed with them. Then we discuss with the stakeholders also the resources and how that could be implemented. And also we had a number of surveys there. So these are some of the methods we had. So the stakeholders mapping, policy Delphi, double bow. We developed a UCL, then the balance scorecard, which has more than 500 indicators, and then the governance for equitable DR3, which we are in process of developing that. And then we have different methods. So it's the ISLA model, but we adapted that for the resource allocations. So we had consider a number of services and storage and use technologies and failure modes. And then we combine services, sources, distribution links, stores, each with different social and economic value. And then we looked at the best way to allocate resources based on different failure modes. And then from the social media, we apply a number of techniques, multi-classification approach techniques to learn a SVC model to distinguish between disaster categories. We end up with 34 disaster categories, and then showing a percentage distribution of the sample messages for each category, and then we train the classifier and so on. So, and then we build up some scenarios. So the innovation aspects and originality and degree of novelty of such approach has a number of elements. Indicators, scorecard, and expert elicitation methods with cross-stakeholder and cross-scale interactions. Metrics are needed to collect by real frequency for making decisions, and define in a way that measures can be consistently applied. Then use of artificial intelligence for digital response, give us an understanding in terms of extreme events. Resource nexus and identifying trade-offs between use of resources under different climatic scenarios demonstrates how scenarios, different scenarios could be there. And looking at different agendas, climate agendas, SDGs, and it's to emphasize more in the equitable DR3. And the basic of the blue economy and its contribution to the green agenda. So this is the business case for change. Oceanic resources must be reevaluated as we evolve businesses to take care of the green agenda. We cannot achieve net zero targets nor the SDGs without considering equally ocean autonomy, but also the green principles. So this type of toolboxes, I think, will span from decision analysis to which really consider different techniques and methods from dynamic type of systems and graph theory and social media to stakeholders mapping, and underpins these nexus thinkings. And this toolbox can only be achieved through strong collaboration and with partners from different disciplines, and this could not happen without that in place. And strong collaboration, and also strong collaboration with different stakeholders. And I finished with my gallery.
Catalina, thank you so much. That was a tour de force. I love your gallery walk, because we know, as well as being a professor, you're a very talented artist in your own right. So it's a lovely touch. Take a breath, Catalina, because we've got a bunch of questions coming in. and people are upvoting them. So I will go through the ones from the most upvoted down. So if you like a question, please vote for it. I'm going to start with Raymond Bleichwitz, our ex-director of the school. So thank you for joining us from Germany, Raymond. Raymond thanks you for the talk, and he says, how do you look at marine ecosystems like mangroves, so reefs, salt marshes, etc., and the potential market for carbon uptake? Could marine spatial planning play a role in aligning interests, and would you include it in your toolbox?
Absolutely, spatial planning, but not only that, is also about regulations, which doesn't really exist in the common understanding of ownerships of this type of projects when we talk about ocean, and so we need a legislation, a common agreement in terms of regulations and legislations, and to be put in place, because we've seen a significant growth, but there are only a number of companies which are effectively on the market in terms of solutions for ocean.
Thank you, Catalina. The questions are being voted on and they're moving up and down, so I'm making sure I keep track of them. A question from Steve Pye on supergrids and financing. One of the initiatives launched at COP26 was the Green Grids Initiative, and the key challenges recognized is in finance, especially making sure that the finance is climate friendly. Have you got any further thoughts on how the challenge of financing grids and how we can tap into climate finance more generally?
Yeah, climate finance, to be honest, finance is one of the biggest challenge we have currently. This is not only for this type of super grids. It's really interesting when you look at the number of projects of long interconnections and based on HVDC and ultra HVDC. It's a significant growth on these interconnections in the past years or so. So financially, it depends really how you do the calculations. You build up an interconnections, or you invest money into microgrids. It depends of how you make that. It depends on many factors, to be honest. It depends also how feasible are these projects, because you need to consider all sorts of variables there, climate variables, not only finance, engineering variables, so how feasible technically are these projects and so on. I would say that finance, to be honest, is a problem in any domain. We still have houses which are not insulated, so there is a finance problem as well. So as long as we have support, we've seen already in the past, if we have support from the government, then for different schemes and so on, then things are moving on. So I think it's more about identifying what could be that combination of solutions.
Thank you, Catalina. We still have a number of questions. I'm happy to go a couple of minutes past the hour, but perhaps quick fire answers from you as well, Catalina. So moving to a question from May Kassar, which has been voted on. May asks, many natural ecosystems are inscribed on the UNESCO World Heritage List. How would proposed use for carbon sequestration impact on their protected status under the World Heritage Convention?
Yeah, absolutely. That is a really good question. We need to be well aware of all these protected areas and so on. So, and probably there will be other areas which are not protected yet and which should be under this. But definitely it's something what needs to be considered for sure when any decisions will be taken, to be honest.
I'm going to move to Tristan's question, which is quite long. So let me see if I can summarize that a little bit. Essentially, he's asking, where do you think the global discussions that could leverage this thinking might be taking place? So he's saying that there are numbers, increasing numbers of oceans conferences, including by the UN and by other bodies, but your message might be too broad for that, focusing on both blue and green. Likewise, you go beyond climate, so it's not just COP. So where's the platform that will cover the breadth of what you're talking about?
Absolutely, it's a really huge topic where effectively you can address some of these issues or get better understanding between some of these sectors or within some of these sectors through this type of toolboxes. So very much the message is we need interdisciplinary approaches. We need tools to integrate tools and more people coming from different disciplines to work together to deliver a better understanding of new pathways or realistic scenarios, I would say.
Another voted on question by Steve, which is also on this issue of institutions. He says, on the toolbox of islands, have you thoughts on experience of building capacity using these tools by island communities? What has worked and what has not worked? Has an international community of users started to develop to provide mutual support?
In what sense, capacity?
I think by the different experiences of the institutions and island communities. So when you take your toolkit and you talk to different islands and the different stakeholders there, have there been lessons learned? Have you done things that just haven't worked?
The biggest challenge with islands, to be honest, is finance. So all the discussions we have discussed with many stakeholders. We had really great sessions back in November, December last year with stakeholders from Mauritius, Fiji, and other islands, and we get more insights in terms of practical stuff, and we adapted our toolbox according to their needs. So every single, I would say all these toolboxes needs to be adapted, needs to be tailored to specific needs. And discussions with stakeholders is key.
So then that leads nicely into Rachel's question about how much does the feasibility of these highly collaborative multi-agency types of projects rely on stable government? Are there areas of the world where governance is simply insufficient?
It's a tricky question, I would say. If I would have an answer, it would be great, fantastic. No, I'm not really sure, to be honest. I don't have an answer to this question. It's the kind of large scale and the scale of the type of project we have in this moment for islands and coastal areas we never had before, to be honest. So we never had so many tools and so many methods to link them together and to work in partnerships. So there were lots of challenges, and there will be more challenges. Definitely, we are in the process of applying these toolbox for case studies. In about 6 months, I can probably answer to this question.
So I'm going to try to complete on these questions. Some of these, just thank you for the great presentation. So Omar, thanks you. There is a question about the recycling of the timeout wind components. Any plan for the island? If I understand this question right, I think it's about how do you manage when wind is blowing or not blowing and demand is there or is not there, particularly in the island context.
Absolutely, we've seen all these sort of situations, and some of islands are facing blackouts plus higher prices and so on. So for that reason, plus challenges in terms of climate change, more extreme weather events and so on. So for that reason, the idea was if we have this kind of mobile interconnected systems, which we can plug in and plug out wherever is needed, then could provide, could help these islands to manage their demand and supply.
And Catalina, the final question, a brilliant question from Derek, which talks about between the land and the oceans, where is the potential to learn more? So where's the next frontier, perhaps, of your research, particularly focusing on how nature conserves energy and minimizes waste?
To be honest, in any of these areas, it's plenty of research to be done. But definitely something what I'm very much interested is to come up with more practical solutions in terms of how we can help these islands or coastal areas to respond to the effect of climate change.
Catalina, thank you for that. I'm conscious of time, and I'm conscious that we've run out of time, so I'm going to leave it there with the questions. I apologize to the people I couldn't get to. I know that you have a very vibrant research group with researchers and PhD students who contribute to this work, and it's shown in your talk. But on behalf of everybody, can I just thank you for a brilliant seminar. And Catalina, you can now go and have your lunch, because I know that you said before.
I need to have my coffee.
And your coffee as well. So Catalina, thank you, and to all our participants online, thank you so much for taking the time.
Okay, thank you everyone. Bye-bye.
Thank you and goodbye. Thank you.